All right, so here's the schedule for the week. We're going to start off with this 03.4 formative, and you don't have a copy of this. We'll just go over this in class. And then in your notes, we have 04 box plots, and I'm going to take you through what a box plot looks like today. You can see the due dates I have coming up for the homework. The 03 I already had due. Try to have that done for tomorrow. 04 homework will be due on Thursday. Tomorrow is the next section on histograms. We don't have any class on Wednesday, but we're looking at our first quiz in here on Friday of next week. I originally had it a little bit earlier, but we're going to move back to Friday of this week. So this is kind of the plan that we have for the week. Let me come into here. And so again, this isn't in your notes anywhere, but let's see what you can remember from some of what we did before. And I know it's been a while. Which measure of central tendency best represents the data and why? So first of all, what do we mean by measures of central tendency? There were 3 M words that we talked about for different kinds of central tendency, different kinds of averages. The mean is what we generally consider to be like the regular average. You add them all up, divide by the number of terms. What's the term that's in the middle? What do we call that one? That's the median. And what do we call the one that occurs the most often? Mode. So the way they're described is kind of what they sound like: median, middle, mode most often. And the mean one is requires the most work. It's the mean one. It's the average. So which measure of central tendency best represents this data? So I could add all these up, divide by 6 and get an average. That would give us the mean. If I put them in order from small to big, I could find the median, the one in the middle. What would be the mode for this set of data? What number occurs the most often? None of them. So there is no mode for this one. Again, the mean, I could add them all up and divide by 6. However, sometimes the mean isn't a good indicator for an average when there is an outlier. This term outlier we'll talk about more today, like how you'd actually calculate it. But do any of these numbers seem like radically different from all the other ones? The 1 does, doesn't it? So the 1 is pretty significant for this. And so because we have an outlier, the measure of central tendency that would best represent that then would be the median. Okay, so that's something that we need to keep in mind as we go forward. We like dealing with the mean and the average because it gives us a true average. But if there is some number that is really, really different, then you're going to use the median. Number 2, the data frequency table. We did a few of these, and again, these can be kind of difficult to try to figure out. If you have your calculator, you're going to want to use it for the mean for sure. What does this mean, and how do we calculate these things? Well, I'll just go down this first column. This first column means that the data, the number 12, shows up 8 times. So if I was to list all of the numbers that were actually here, I'd have the number 12 written 8 times. And the number 14 would be 7 times, and 16 would be twice, and so on and so forth. We don't want to have to write out the entire thing and go about it the long way. We want to do it a quicker way. So we came up with a strategy for that. If the number 12 was written down 8 times, and we're trying to find the mean, wouldn't we end up adding them all together eventually anyways? Right, I just erased all of them, but 12 plus 12 plus 12 plus 12, a total of 8 times. What is the same thing as adding 12 to itself 8 times? 12 times 8. So instead of like actually adding them, if we took 12 times 8 plus, then what would we have to do with this one? 14 times 7, right? Use your calculators. Can you figure out what all of these numbers would add up to? Because when you calculate the mean, remember, you add up all the numbers, and that's what we're in the process of doing. Adding up all the 12s, adding up all the 14s, then add up the 16s, the 18s, the 20s. So when you find the mean, remember, you add up all the numbers. That's what this numerator part is doing, divided by how many total terms there are. Well, if there are 8 of these and 7 of those and 2 of those, wouldn't you just be adding all of these together to figure out how many terms there were? Okay, so total all of those, what does that come out to? 21. So now you have your numerator, whatever that came out to, divided by 21, and you can find your mean or your average. 14 point, give me 2 decimal places. 28. And then as I look at what's up here, does that answer make sense? Well, 14 is within our data range. I think that makes sense. There's a lot more of these smaller numbers and the bigger numbers. I'm thinking that probably is a pretty accurate answer then. All right, so there is the mean. We can use this data frequency table to find a mean. The median. So the median would be like when we get rid of the smallest number, get rid of the biggest number, get rid of the next smallest, get rid of the next biggest. We'd have these two in the middle. Then you would have to average them together, 15 plus 17 divided by 2, and then 16 would have been the median for this one. Chop off numbers from the biggest and the smallest. How do we do it like this? Well, we're going to do it in big chunks. Instead of just getting rid of the one biggest and the one smallest, let's get rid of, well, the one biggest, which is this 120, right? I'm going to get rid of the biggest number. And then the smallest number, I'm going to get rid of one of these 12s, so now there's only 7 of them left. Right? I got rid of the biggest and the smallest. Then let's get rid of the next 3 biggest numbers. Getting rid of an 18, 18, 18. That's what this part represents. The number 18 shows up 3 times. So I'm getting rid of the 3 biggest numbers. If I get rid of the 3 smallest numbers, I'm getting rid of a 12, a 12, and a 12. If I get rid of 3 of them, now there's only 4 left. Okay, so I'm going to keep chopping off here. Now let's get rid of the 2 biggest numbers. There's a 16 and a 16, so get rid of the biggest 2. Get rid of both of those 16s. Get rid of 2 of these, so now we're down to only 2 of those. So we've been chopping off from side to side. Now we have 2 12s left. So let's get rid of the 2 smallest numbers. Let's get rid of the 2 of the biggest numbers. There were 7 of the 14s. If we get rid of 2 of them, that means that there's 5 left. So we've been chunking off, getting rid of big numbers and small numbers and big numbers and small numbers. All of a sudden in the middle, the number 14 shows up 5 times. And as you start chopping those left, what's going to be the median? The last remaining 14. So the median, we chop off to get there. If you want to list all of them out, you can, but this is a much quicker way to do it. The last thing is the mode. So the mode, if you understand the data frequency table, the mode, you can just pull it right out of there. Go ahead and turn to your friend. What do you think the mode is for this one? Which number shows up the most often? Go. The number 12 is on there 8 times, so 12 would be our mode. Last question. Biased or unbiased? Mr. Estabrook tells his students that one of his childhood friends is on The Voice, which was true about 4 seasons ago, I think. He plays one of his friend's songs in class. All of his students get a survey asking about who is their favorite singer on The Voice. Would this be biased or unbiased? It'd be biased. Convenience or voluntary? Was it convenient for me to ask the people who only knew about one person? Yeah, and it wasn't like a little bit voluntary. Like, did you have an option though? No, like I made you answer the question. So this would be more of a convenience bias. This was like, what is your favorite sport? And you asked the people who all play the same sport, what is your favorite thing? You didn't, you're not getting a wide variety of people. If I played everybody from The Voice from that season and then asked you who is your favorite singer, then that would get rid of that bias. But the convenience is I made it very simple for you to answer my question based off of your background. Okay, so there is our 03.4 formative, just a little review of some of the stuff we've looked at. Now, in your notes, we're looking at box plots. So go ahead and turn to this page. You've seen graphs before. We made a pie chart, a histogram. You've seen a lot of charts before. The box plot is something that looks a little bit different. And this is something that hasn't been around for a long time. Like if you were to ask your parents, have you seen a box plot before? A lot of them might say, no, I really haven't. But it is a really useful type of plot to look at as we're comparing things. And if you're like me and you look at this first page, it can almost seem overwhelming. Oh my goodness, there's so much stuff there. What am I supposed to do with that? How do I make sense of that? You're probably not alone. Some of the things I do want to point out on this before we just jump into an example and like really learn by doing is talking about percentiles. Have you guys heard of percentiles before? Yeah. If I said that you scored in the 50th percentile on a test, that does not mean that you got 50% of the problems correct. That means you beat 50% of the people. 50% of the people were above you, 50% were below you. If you scored in the 80th percentile, that means you beat 80% of the people. It doesn't mean you got 80% correct. You could have got like 90% correct. You could have got 50% correct. It doesn't tell you how hard the test was. It measures you against other people. And inevitably, there's always going to be an upper half and a bottom half. Someone's always going to score at the bottom. They might have gotten a really good score. Say somebody in here got an 85% on a test. Awesome. And you were the lowest score. Well, you would be at the very lowest percentile. It happens sometimes. Percentiles are a way to compare. And comparing is good, it's bad, but it gives you a chance to compare so you can see how difficult things are. So all of this, we're going to talk about outliers. That's been mentioned before as well, how you actually calculate those outliers. So there is a nutshell of what was on that page. But again, I usually learn better by doing, so let's go ahead and turn the page and jump into our first example. It says, given this data set, find the 5-number summary. All right, so we're looking for the min, the max, the median, quartile 1, quartile 3. Not necessarily in that order, but these are the 5 things we're looking for. The 5-number summary. Again, it's a ranking system. Good news is that all of these numbers are already in order. I don't have to write them all over again, thankfully. So as I look at this list of numbers, I should very easily be able to look at it and say, aha, the minimum number is 2. The maximum number is 23. And now for the other ones. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 numbers that are in here. So to get the median, remember median sounds kind of like middle. If there's 12 numbers, what's going to be right in the middle? 1, 2, 3, 4, 5, 6. So there's 6 numbers below, 6 numbers above. So I'm putting my big spacer right here. That represents the middle of all these numbers. If there's an odd number, I'd be circling the one that's right in the middle. When there's an even number, I just put a marker that splits. There's 6 below, and there's 6 above. So this blue big mark right here represents the median. What would that number be then? 11.5. It's got to be right in between those. So our median, even though it isn't on the list, is still 11.5. So we've looked at medians before. Minimum and max, not terribly difficult concepts.
So if it's an odd number of numbers, which one would you choose?
If it's an odd, like if it was, like, say, 5, 7, 8, 9, 14. So then with this, what's right in the middle? 8. So 8 would be the actual median. Then we'd actually would use it rather than putting a marker in there. So when you have an odd number, it's actually nicer because I don't have to like split the difference. All right, what does Q1 mean? Quartile 1 means what is the median of the bottom half? Like here's the bottom half of numbers, there's the top half of numbers. So as we're looking at the bottom numbers, there's 6 of them there. Where would be right in the middle of 6? Be right here. This splits the bottom half. There's 3 below, 3 above. So this would be our quartile 1. What's right between 7 and 8? 7.5. So 7.5 is our Q1. If that's Q1, Can you anticipate what Q3 is going to be? What is the third quartile? So I'm looking up here, the top half, it's going to split the difference right there. That number is 14.5. So this is your answer. What this represents is the minimum would be like the 0th percentile. It's the very bottom. There's nobody below that score. The maximum then would be what percentile? 100%. They're at the top of the class. What would be the percentile for the median then? 50th percentile. They are, I put percent, I shouldn't do that. It's percentile, it's different. 50th percentile, they're better than half the class. They're right in the middle. Then what percentile would the first quartile be? 25%. 1/4, 25%. 25th percentile. And quartile 3, third quartile would be 75th percentile. That's what these things mean. They're different ways of saying that same idea. So you take a standardized test, you get your score, it gives you a percentile, and we can rate it in these different quadrants. Bottom 25%, the next 25%, the next 25%, the top 25%. So that's finding the 5-number summary. Then we want to make a horizontal box plot and show the 5-number summary. So we're going from the smallest number of 2 to the biggest number of 23. Kind of like a number line. I need to get all the way from 2 up to 23. And I don't really want to put 23 little marks on there. Generally, I want to put somewhere between like 8 to 12 marks on there. So if I go up by a scale factor of 2, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm going to be able to fit them all on there. Okay, so make a horizontal box plot. Horizontal means side to side. Show the scale below. Okay, so there's my scale factor. I went up by 2s. I don't want to go up by too much. Otherwise, it's hard to be very precise on those. And I really don't want to go up by 1s unless I have to. So this is a good spread. Write the 5-number summary next to the graph. Okay. We're going to start with the median at 11.5. And put a line like that. So median taken care of. Quartile 1 is at 7.5. I'm going to put another line like that. Quartile 3 is at 14.5. Put another line. And then we draw a box around all of those. So this represents the middle 50% of the scores, the middle 50th percentile. And then for the minimum, we draw a line till we get there. And for the maximum, we draw a line until we get there. Those are sometimes called the whiskers on the outside. Sometimes these are called box and whisker plots. And then it says, write the 5 numbers next to the graph. So our numbers were 2, 7.5, 11.5, 14.5, and 23. There is your horizontal box plot. So when you look at this, we can see how the numbers are spread out. 50% of the numbers are in between these two boxes. 25% spread out on this line, 25% spread out on that line. The longer these lines get means the more our data, our numbers are spread out, which means that there's more likely to be an outlier if this is a really long line that has a big list to it. So 5-number summary gives us our box plot. Number 2. Same idea, but unfortunately what's not true this time? Not in numerical order. So we have to get them in numerical order. So I'm going to pause for a second. Can you get these into numerical order? All right, so here is the list of all of our numbers now in order. And we need to find the 5-number summary. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is where it splits the difference. There's 8 below and 8 above. I can write the 5-number summary in any order. Min, max, median, quartile 1, and quartile 3. These are the 5 things we're looking for. Minimum is 12, maximum is 80. The median goes right between the two 34s, so it's going to stay at 34. Quartile 1, see there's 8 numbers at the bottom, so quartile 1 would go right where that yellow marker is. There's 4 below it, 4 above it. So the number that would go right between those would be a 23.5. Quartile 3, the midway point for the upper half. So there's 4 above, 4 below. It's going to go right here. Looks like a 46. So there's our 5-number summary. Part B, find the IQR and find if there are any outliers. So this is a new term for us. IQR stands for interquartile range. Interquartile range. Inter means between the quartiles. We have quartile 1, quartile 3. Range means how much space is between them. What they're asking for, what is the difference between Q3 and Q1? How much space is there between the 3rd quartile and the 1st quartile? So you're going to take 46 minus 23.5. I believe that comes up to 22.5. Okay, so the first question is find the IQR. There's the interquartile range. That's how much space is between the 1st quartile and the 3rd quartile. And we use that to see if there's any outliers. Now, as you look at this list of numbers, let's predict. Are there any numbers on this list that look significantly different than the other ones? Small or big? Big. Doesn't that 80 seem a little bit out of place? Like 12 is kind of close to 19. 80 and 56 seem like they're off by quite a bit. So the 80 might be an outlier, might be kind of close, it might be too far away. If it said 800, we'd say, yeah, definitely it's an outlier, but maybe it's just on the verge of being close to not quite being an outlier. What could these numbers represent? I don't know how many times somebody does something, everybody's doing this, like how many push-ups people could do, right? And all of a sudden somebody comes up like, I can do 80 push-ups. So it seems like it's quite a bit of a difference than everybody else's. And, you know, maybe there's like somebody who's really strong who can do like 80 push-ups at one time, great. But it does seem like it is pretty significant. So determine if it's an outlier. What we do is we first calculate this IQR. Then with your calculators, I want you to multiply that always times 1.5. So we need the calculator for this. Multiply that 22.5 times 1.5. Does that come out to 30 something? 33.75. Okay. We want to see how far does this stretch? So we're going to compare your third quartile, the 46 plus 33.75. We're always taking where this third quartile is at, and we've evaluated that to be 46 earlier. So on your calculator, take 46 plus 33.75. Is that 79.75? Okay, and then you're also going to take Q1 minus 33.75. We're trying to see if there's a big outlier and if there's a small outlier. So look back at your list, take Q1 minus the 33.75. Is that negative something? Negative 10.25. So what we've just looked at here is, based off of this interquartile range and where Q1 and Q3 were at, are there any numbers that are bigger than this? Yeah, we wouldn't have, like if the numbers were like comparatively of the same size, we wouldn't expect to have anything bigger than that. Were there any numbers smaller than negative 10.25? No, so there weren't any small outliers, but 80, as we suspected, was an outlier that was too big. Not by a whole lot. It wasn't crazy, crazy big, but it was outside of the expected values. This is where this is stats. We talk about outliers. How do you actually calculate an outlier? There it is. Now, were there quite a few steps involved in that? Yes, there were. There definitely were. This is your first time seeing it, so don't think I can't get this. This is too much for me. Give yourself a chance. There's a process of how to do it. Last thing, part C. Can you make the box plot? We did one of those just a little while ago. Look at what we did up above, and it's telling you that we need a scale factor again. We need to go from 0 to 80. I don't want to put 80 marks. I don't want to go up by 2s and put 40 marks. Generally, we're putting somewhere between like 8 and 12 marks on there. What might be a good scale factor? Go up by 5 would be okay. I'm going to go even bigger than that. 10? Let's go up by 10s. Again, look what you did it before. Horizontal box plot like we did before. There's the box in the middle, the whiskers on the outside. Show the scale factor, modified 5 numbers, and any outliers. And because this 80 was an outlier, we usually put like a little star next to it to show that it's a little different. It falls outside of the norm, and we figure that out by doing that IQR process. If I scroll back to the first page, here is the IQR that we're talking about, 3Q minus 1Q. And then to find the outliers, 1.5 times the IQR, take Q1 minus that, 3Q plus that. If anything falls outside of those numbers, that's what makes it an outlier. That's what we did on that part of it. So there's like a written explanation of what we just did on that part. Go to your homework packet. I'm going to give you some time to work on these. Let's see how well we recall the things we need to write down for the 5-number summary. There are 5 things. Can you list the 5? And again, it doesn't matter the order, but can you list the 5 things that need to go in the 5-number summary? Min, max, median, as well as Q1, Q3. So find those 5. All right, so it says you'll draw 2 parallel box plots. That just means that once you get down to here, you're going to do a box plot for the top one and then for the bottom one. All these little dashes are just trying to separate them. You'll figure out the scale factor. You can use the same scale factor for both of those. So don't let this part of it make you think it's any weird. Just do your top one and your bottom one. And I want to go through 3A with you. Write down the 5-number summary. At this point, hopefully you remember what those terms are. What are the 5 things we have to put in our 5-number summary? Min, max, median, what else? Q1 and Q3, right? Okay, so minimum, are these in order? Yes, minimum 12, maximum 73. 10 terms. So our median's going to go where that blue is at. The median is a nice 30.5. But here's the first time we're going to be given an odd number of terms. So hopefully min and max you feel good with. The median, we've done things like that before. We split the difference at 30.5. But for this lower half, there's 5 terms. What then would be Q1? Don't have to split anything this time. It is 23. And for the upper half, 36. So it's actually kind of nice when we don't have to split those. So an odd number, we just grab the one that's right in the middle. So 5-number summary. Eventually, you'll do the box plot at the bottom. But to find the outliers, here's where I want to help you again, because we only did one outlier problem together. To find the outliers, you need to calculate the IQR. It doesn't actually say you have to do it, but you have to do it to determine outliers. So calculate the IQR. What does it stand for? The interquartile range. What's the difference, the range, in between Q1 and Q3? So 36 minus 23 is 13. That is our IQR. So you have to do that. There's a step 1 for finding the outliers. Step 2, we're going to multiply. What do we always multiply this by? Say it louder. 1.5. Always 1.5. So it was Q3 minus Q1. Take that number times 1.5. Is that 19.5? Right. And then step 3. Take Q1 minus 19.5. We're looking for a small one. So like how far to the left would we go? and then take Q3 plus 19.5. Looking for one on the big side. Just check my arithmetic. Am I getting the same numbers? 3.5. Is there anything on our list smaller than 3.5? So there's no small outliers. Is there anything on our list bigger than 55.5?
Yeah.
Yes. So 73 is a big outlier because it's outside of that. When we're finding these numbers that are right here, we're looking for the expected values that we would get, and 73 was outside of that. So finish these. Your due date